Hello and welcome to a new video on IGCSE Classified Paper 2, Physics. In this video, we shall be discussing the topic of refraction laws. We will begin with conceptual questions. In which situation is the wavelength of the wave changed? So you should know that if light passes from a medium to another, the wavelength is going to change. You have V equals lambda F. And during refraction, the frequency remains unchanged, but the velocity and the wavelength both change. For more information about this, you should also watch the video called Wave Processes. It doesn't have to do with light waves in particular, like this video, but it does discuss the idea of reflection, refraction, and diffraction for waves in general. So in this case, light from the sun passing from air into water is the correct choice because the wavelength will change, because this is the definition of refraction. When light moves from one medium to another, like air and water. What about the other choices? Radio waves traveling from an Earth satellite to the moon. So these are in vacuum anyway, so there's no change in medium because there is no medium to begin with. So there's no refraction in space, definitely. And then for choice C, sound reflecting from a wall. In reflection, everything is conserved except direction. Only the direction changes, so nothing else is going to change. In D, water waves passing through a narrow gap. This is diffraction. And again, in diffraction, the wavelength does not change. So the correct choice here would be choice A. The diagram represents water waves in a tank. Which diagram represents a wave that changes speed? Again, for the wave to change speed, it has to refract. Refraction is the only case where the wave would change speed. So diffraction in A and B, these are both diffraction. These would not work. In C, this is reflection. So these are diffraction. And in C, this is reflection. As you can tell, the waves are hitting the surface and going back. So again, this doesn't work. The only correct choice here is D, because a change in medium occurred. So the waves were moving in deep water, then now they are moving in shallower water. So in this case, refraction occurs, and therefore the change in speed can happen. Whether speed or wavelength, they both change during refraction. Again, for clarity, let me write the word so that you can distinguish the three properties or the three processes. You have reflection, you have diffraction, and you have refraction. The only one that has change in speed and wavelength, you should remember this equation, V equals lambda F. The only one where changes occur in V and lambda is refraction. So D is the correct choice here. What causes the change in direction when light travels from air into glass? So not only does the wave change in speed and wavelength, but of course it also changes in direction because it bends. During refraction, some sort of bending occurs. So why is that? Why does that happen? Because the amplitude changes? Not really. Because the color changes? Again, not so much. Because the frequency changes. We said frequency is the only thing constant. So V equals lambda F. The frequency depends on the source of light. So for example, the sun. But then if it changes medium, what the two quantities that would change are V and lambda. So either the speed or the wavelength. So frequency is wrong, but speed is correct. So the speed of the light changes. This is the correct answer. The diagram shows a ray of light incident on the surface of a rectangular glass block at 90 degrees to the surface. Which quantities remain unchanged as the light enters the glass block? So the light was in air and now it's in glass. So there is a change in medium and refraction occurs. So when refraction occurs, remember V equals lambda F. This changes, but the frequency remains the same. So since we're looking for remain unchanged, we definitely don't want speed because speed changes. We definitely don't want wavelength. So by elimination, A is the correct choice. But you might be confused as to why the direction here is listed as unchanged, even though I said that normally in refraction, the direction changes. Well, in 99% of the cases, the direction would change, but in this particular exception, the incident ray was normal to the surface. So like the angle of incidence is 0, and we're going to come to that later in the same video. But here the angle of incidence is 0, so the angle of refraction is 0 as well. So it's just going to continue in the same direction. No bending will occur, but V and lambda will still change. It's just that because the angle is 0, the angle of incidence, I mean, so there will be no bending here. The angle of refraction is going to be 0 as well. So anyway, the correct choice here is choice A, direction and frequency. Next, we move on to equations. So not just concepts anymore. We're going to deal with numbers a little bit. So light passes into a glass block, which here is the angle of refraction. So before dealing with questions that have numbers in them, I just wanted to show you this question so that you never ever make this mistake. All right? So here the light is incident from air and moving into the glass block. So the angle of incidence is somewhere here, and the angle of refraction is in the glass. It's in the other medium. But which one is it in both cases? We always measure from the normal, not from the surface. So for the angle of incidence, D is wrong, C is right. For the angle of refraction, B is wrong and A is right. So since we're looking here at the angle of refraction, we are looking for choice A, since this is what presents the angle of refraction. So A is the correct choice. The diagram shows light traveling from glass to air. What is the angle of refraction for this ray of light? So again, the incidence here is in glass and the refraction is in air, but we do not measure from the surface, we measure from the normal. So this is the angle we're looking for. And of course, the normal forms a 90-degree angle, so all you have to do is just 90 minus 20, and the angle is 70. So this is the correct answer. D is the correct answer here. Next, we start exploring the equations that have to do with the refraction of light. So we said that during refraction, three things are going to change. We said V equals lambda F. So you have V and lambda. And we also said that the direction changes. And we measure this change in direction using the angle. So the angle is theta. Now, there is a very simple equation that you need to memorize in order to figure out all what comes next. It's just N1 over N2 equals V2 over V1 equals sine theta 2 over sine theta 1. So as you can tell, one has to do with one medium, like maybe like the medium of incidence. So here, anything that has one has to do with air, for example. And anything that has two would have to do with glass. So we can actually rewrite the equation for this problem using other subscripts. So this is the general equation. But like for this problem, you can always say N air over N glass equals. And then you flip. Can you see that here you have 1 over 2, but in all the rest you have 2 over 1. So it becomes V glass over V air. And sine theta glass over sine theta air. Right? And one other thing you should know is that N air is actually always 1. So this N air here, this is always 1. So if we want to get N glass, what would we do? We would just flip this equation to get a different equation. We just get N glass over 1, which really doesn't matter. We don't have to write it. I'll just write it for clarity. So N glass over 1 equals, so if we have N glass in the numerator, then anything that has G will be in the denominator. So we have V air over Vg, because N is the opposite of all the rest. So if we have Ng up, then we have Vg down. We have sine theta G down as well. So we have sine theta A over sine theta g. So this is what you should bear in mind, which is that the n opposes the v and the theta. If the n1 is up, then the v1 and the theta1 will be down in the denominator, and the opposite is true. And we can actually discuss the physics of that. It's not just something to memorize, but to be honest, just knowing this rule mathematically is simpler and shorter to answering questions of this sort. So in this case, we have two things we want to discuss. Or actually here, they don't really care about velocity. So let's just worry about this one. So we have n glass over 1 equals sine theta air over sine theta glass. And theta air is always measured from the normal. So that would be W. And theta glass, again, is measured from the normal. So there is a letter X here that might not be very obvious. So that would be X. So they said that the refractive index of the glass is labeled as N. So basically N equals sine W over sine X. This should be the correct answer, which is D. So this is the equation that you need to know for refraction, and it's the equation that we're going to use throughout the rest of this video. The most important equation for me is that the one written in red. So let me just circle it here. This equation is the most important equation. You can derive literally anything else from this equation. And we'll see more examples soon. So anyway, for this problem, the correct answer is D. The diagram shows light passing from air into glass. Two angles P and Q are marked. Which pair of equations can both be used to calculate the refractive index of glass? So let's start with the equation that we wrote before. N1 over N2 equals V2 over V1 equals sine theta 2 over sine theta 1. And then let's make some alterations. Instead of 1 and 2, we're going to use air and glass. We're just going to say N air over N glass equals V glass over V air equals sine theta glass over sine theta air. So you might be asking yourself, why do I insist on writing it in this form when we already know from the last problem that N air is always 1? Because what if you get a question where one of the media is not air? What if you get a question where it's going from, I don't know, from solid to liquid, for example? So you have to know the equation with N1 and N2 because this is the general equation, regardless of whether air is part of it or not. So anyway, in this equation, we're going to remove N air and we're going to put 1. And they are calling N glass here just N. So we're just going to remove N glass and we're going to put N. So 1 over N equals V glass over V air, which is equal to sine theta glass over sine theta air. And now what we have to do is we just flip the N. So because in all the choices, they have N in the numerator. So we just flip all the fractions. So we have V air over V glass, and we have sine theta air over sine theta glass. Let's look at the choices. We have VA over VG, which is speed of light in air over speed of light in glass. So this would be correct. This would be wrong. This would be correct, and this would be wrong. We have air in the numerator. And then for the sine theta, we have theta air in the numerator, and theta air is basically P, and theta glass is basically Q from the drawing. Because we know that air corresponds to P and glass corresponds to Q, and they are put in correctly with regards to the normal. So we don't need to do anything except just remove theta air and put P. Remove theta glass and put Q. So it becomes sine P over sine Q. So this is correct, but this is wrong. So the only choice that has two correct parts is choice A. And this is the choice we're going to go with for this question. Excuse me. The diagram shows light passing from air into glass. The glass has a refractive index of 1.5. What is the angle of refraction in the glass? So again, let's write our equation down. Instead of writing it in terms of 1 and 2 and then writing it in terms of air and glass, we can just do it with air and glass automatically. So NA over NG equals VG over VA equals sine theta G over sine theta A. Now, in this question, do they mention velocity at all? Not really. So we don't really need this part of the equation. And we can start by writing n air equals 1 as well, just to simplify. So we just get 1 over ng. And you might as well actually put 1.5 instead of ng because they've already given that to us. We know that the refractive index of glass is 1.5 anyway. We can just put 1.5 here, 1 over 1.5. Remember, this is given. Equals sine theta air, sine theta glass over sine theta air. So what is sine theta air here? Or what is theta air at least? Is it the 60 or the 30? We said it has to be the angle with the normal. It has to be the 30. So instead of theta air, I'm just going to cross this out. I'm going to write 30. And then we're going to cross multiply. So we have 1.5 sine theta G equals 1 sine 30. And then in order to get theta G, which is the angle in glass, all you have to do is divide by 1.5 on both sides. So this gets crossed out. And then you just evaluate the right-hand side. So sine theta G equals 1 sine 30. I would recommend you first write 1 sine 30 on the calculator. And then you find that in my calculator, I got 0.5. And then after that, I'm going to divide the answer by 1.5. So I get 0.5 divided 1.5, which is 1 over 3. And then in order to get theta, you get the inverse sign. So basically, on a regular calculator, you would find it by clicking on shift and then sign. This would be sine inverse. And then you would write here 1 over 3. So let's try that out. So my calculator gave me 19.47 degrees. And I'm going to go with choice A accordingly. Light enters a glass block at an angle of incidence of 46. The light refracts at an angle of refraction of 26. What is the refractive index of the glass? So we don't have a drawing here. We can just use the same equation again. N air over N glass equals V glass over V air equals sine theta glass over sine theta air. And N air is 1. And theta glass, so bear in mind, because this is a bit tricky, you might be tempted to use 46 for glass. That is not going to be correct, because light enters a glass block. So it's initially in air, and it enters at an angle of 46, and then it refracts at an angle of, or actually, I misdrew. So it enters at an angle of 46, and then it refracts at a smaller angle here of 26. Also, if you're confused, you need to think of it logically. As you can tell from the equation, the n is opposite to the theta. So the higher the n, the smaller the theta. And n has to do with the density of the material. So air has the least density whatsoever. So it's always going to have the bigger angle because it has the smaller n. It will always have the bigger angle. So if you have air and something else, the bigger angle is definitely in air, regardless of incidence and refraction. So theta air is 46, and theta glass is 26. And we are required to find n glass. So let's rewrite the equation. Of course, we do not need speed here as well. Why do I insist on writing the full equation? Because sometimes they're going to give you information about both the angle and the speed. So you might as well just be familiar with the entire equation to begin with. So we have 1 over ng equals sine 26 over sine 46. Since we're not trying to find an angle, there will be no shift sign. There will be no inverse sign here because you're already given both angles. So you just have to calculate the side on the right. You can just figure out the numbers. We can do sine 26. This gives us 0.438. And then we try sine 46 as well. This gives us 0.719. And then we cross multiply. And always remember that air has the smallest n and has the biggest theta and the biggest v as well. Always keep that in mind. So even without doing any calculations, we have to figure out that air has the smallest n, and the smallest n is 1. So the refractive index of the glass cannot be smaller than 1 because we said air has the smallest answer. So it's definitely not a decimal. It's not a 0 point something, I mean. It's either 1.64 or 1.77. Let's get back to cross multiplying. We have 0.438 Ng equals 0.719. So Ng is equal 0.719 divided by 0.438. Let's try this out. It's I got 1.64. So it's actually exactly the same as C. So C is correct. 1.64 is the correct answer. Light traveling at a speed of 3 times 10 to the power of 8 strikes the surface of a glass block and undergoes refraction. The diagram shows a ray of this light before and after it enters the block. What is the speed of light in the glass? So remember when I was just telling you, always write the full equation because you might have a problem that gives you both angles and speeds, like this problem. So here we have n air over n glass equals v glass over v air equals sine theta glass over sine theta air. Now, V air is something you should know, and it's actually given in the problem because light is traveling at 3 times 10 to the power of 8. N air is always 1, we know that. We are not given N glass here. Yeah? So this is just something that is unknown, and we might not need to get it to begin with. We are required to find V glass, so let's call that just like X for now. This is what we're trying to find. The angle in the glass is 33. It's evident from the drawing. So sine 33. And the angle in air is 55. So sine 55. So let's figure out what we need here. We need to find X, and we have these quantities are all given. So we don't really need the n's in this problem at all. Just cross out the n's. And we can cross multiply. We can say X sine 55 equals 3 times 10 to the power of 8 times sine 33. And you can just find sine 55 and sine 33 to make life simpler. Sine 55 is 0.819. Sine 33 is 0.544. So this is 0.544. And we need to figure out x. So I can just say that x is equal to 3 times 10 to the power of 8 times 0.544 over 0.819. I always like to remove the 10 power whatever outside because it makes life simpler, to be honest. So here I have 10 power 8. Just ignore that for now. Multiply these two numbers and then divide the answer by the third. I'm going to do on the calculator 3 times 0.544. And this gives me 1.632. And then I divide by 0.819. And this gives me 1.99. So 1.99 times 10 to the power of 8. So definitely 2 times 10 to the power of 8 is the correct answer here because it's the closest to 1.99. So we're going to go with B. Light traveling in air enters a plastic block at an angle of incidence of 62. The plastic has a refractive index of 1.48. What is the angle of refraction? So same logic, same idea. Let's first write NA over NP equals sine theta equals VP first over VA equals sine theta P over sine theta A. And let's figure out what we need and what we don't need. Here they did not mention speeds at all. There's nothing that has to do with velocities at all. So we just remove this from the equation. Of course, N air is 1. And NP has a refractive index of 1.48. So we can just write that as well. And the angle in air is 62, and it's written correctly with the normal. So we take it as it is. So this becomes 62. And then we cross multiply. So 1 sine 62 equals 1.48 sine theta in plastic. And then we divide by 1.48 to isolate. So let's figure this out on the calculator. 1 sine 62. I would recommend you calculate the numerator first and you press equals. And then you divide by 1.48 because a lot of students make the mistake of writing it one time on the calculator. And what the calculator ends up doing is it divides 62 by 1.48 and then it gets the sign of the answer, which is not what you really want to happen here. So 1 sine 62 is 0.882. You can just write here 0.882. And then you divide that by 1.48. And then the answer here is going to be 0.596. So 0.596 equals sine theta p. The final step is to shift sine 0.596. Get the inverse sine of that. So shift sine 0.596. And theta p is equal 36.58. And the closest to that is 37. So we're going to go with C as the correct answer. And this brings us to the end of our video. I hope this has been beneficial to you. Thank you for watching.